Okay, so this question is asking which polynomial is prime? And you have your choices here. This little chart is handy to have. It talks about, a few different ways to factor and patterns to look for. Well, if you notice on these, the first term is cubed, so it's probably going to be a difference of cubes or sum of cubes. And the way you'll know is if you take the second term and try to see if it'll factor into a perfect cube. So, for example, if we take 1, okay, so let's look at the one that was selected but isn't correct. If you take 1 and you multiply it by itself 3 times, it's 1, right? So you could rewrite 1 as 1 cubed, because 1 times 1 times 1 will get you back to this 1 right here. Okay? Now, if you're not sure how to find that easily, 1 is easy, right? But let's look at 64, okay? So you can ask yourself what times what times what would equal 64. That's what you're looking for. So if you're not sure, you can always use guess and check. Start with 2 and say, okay, 2 times 2 times 2 is what? Well, that's 8. Okay, so nope, that's not 64. I need to go high. Okay, so something you can do on your calculator that will help you figure this out faster if you have a graphing calculator is you can hit your little caret button and do parentheses 1 divided by 3, and that's the same as taking the cubed root of a number. Oops, not 63, 64, right there. And that'll find the answer for you, on your calculator. But like I said, if you aren't sure, if you're not sure how to use your calculator that way, just keep guessing and checking. It actually won't take you too long because 4 times 4 times 4 is 64. So we already did 2 times 2 times 2, which is 8, and you're thinking, oh man, that's going to take me forever to get to 64, but it really doesn't. You've probably heard of exponential growth. It goes very quickly, so it doesn't really take you too long most of the time to find the perfect cube. So in other words, I could rewrite this as x cubed minus 4 cubed, just replacing the 64 with 4 cubed because 4 times 4 times 4 is 64. And then paying attention to your sign is the key thing here. If you pay attention to the sign, it's the difference of cubes for this particular option. And so you just follow the pattern that they give you right here, if you were to factor it. So I'll just show you how you can factor it. But basically, the answer to the question is going to be, for this option is going to be that it's not prime because you can factor it. Prime means that you can't factor it. You can't go any farther. So how this works is you take your first perfect cube minus your second, without the cubed part, so just x minus 4. And then in the next parenthesis you have to take your x and you square it, or whatever your first term is, you square it. And then you do plus a times b, so you just multiply those together. So we're going to have plus 4x, 4 times x is 4x, and then the last one is you square this number, the second perfect cube. So you'd have plus 4 squared, and we aren't going to keep going, but if you were, the only thing you'd have to do is just, rewrite 4 squared as 16. So the question doesn't ask you to actually do all that, but I just wanted to show you that you can factor it, and that's how you factor it. So this would not be prime. And then, again, this one is not, prime because we could factor that one. It's also perfect cubes. 1,000 is also a perfect cube. If you do 1,000 to the 1/3 power, you get 10. So this would be factorable as well. So that's not going to be an answer. So this one is our answer, and the reason is because 49 is not a perfect cube. You could rewrite this as 7 squared. 7 times 7 is 49, but there's no number where you can multiply 3 numbers, 3 same numbers together to get to 49. And it doesn't follow, the difference of squares or a perfect square trinomial pattern either. But the key thing that really helps you're probably looking for one of the difference of cubes or sum of cubes is the first term being a perfect cube. So if you see that, then probably want to try to see if the second term would be a perfect cube as well. Okay, look at this one. This one has 4 terms. In problems where you see factoring going on and you have 4 terms, the most typical type of factoring, the most typical thing you want to look for is grouping, factoring by grouping. And what that means is that you put your first 2 terms into a group by putting parentheses around them, and then your second 2 terms into a group by putting parentheses around them. And so you pull an x out of here. That would be, you know, something that x squared and 2x both have in common. You can take an x out. So we'd write x out in front, a parenthesis, and we write what's left. So if we have x squared and we take an x out front, we only have 1x left. And then if we look at our second term inside that group, if we pull an x out, then this x goes away. We just have the 2, the positive 2. So we have plus 2. Okay. So this takes care of that part. So I'm going to switch colors. Okay, now we're going to look here, and we're going to look for a greatest common factor there. So if we look at x, y, and 2y, they both have a y in common. So that's what we're going to pull out of that group. So we're going to put plus y. So notice this sign is actually just going to stay the same. And then you're going to see what's left. So you're going to say, if I pull a y out of here, you're going to have just x left. And then if you pull a y out of here, you're going to have plus 2 left. Now, if factoring by grouping works, what's going to happen is that you're going to have the stuff that's left in your parentheses is going to match. So the trick here, and this is hard to see at first, I'm going to underline, this is the pink things that I'm underlining there are actually terms. So just like when we were up here and we looked at x squared and 2x and we said, okay, they both have an x in common, I'm going to pull that out in front. Well, these both have an x plus 2 in common. So you're going to pull an x plus 2 out in front and write what you have left. So if I have an x plus 2 that I pulled out of this term that I underlined in pink, then what's left is just the x right here. And then if I pull an x plus 2 out of this term, all I have left is this positive y right here. So I put plus y. And then you have to match it to one of these. It's actually choice D. Ours looks a little bit different. It's just a flip-flop of that. But remember, with multiplication, since there's nothing in between those parentheses, this is indicating that x plus 2 is being multiplied by x plus y. And so you can put those, flip-flop the parentheses, and it's still the same answer. Okay, last one. It says, which is equal to 1/8 f cubed minus 1? All right, so again here, what they're doing is, factoring. And because of the cube here, I'm going to look at my factoring patterns chart to help me out, and I'm probably going to look at one of these, cubes. Most likely it's going to be difference of cubes if it's going to, factor into anything because of the subtraction sign there. So I'm looking at the cubed and the subtraction sign to tell me that it's probably going to be difference of cubes. So what I want to do, it's trickier with the 1/8, okay? But you want to think, okay, 1/8 is a fraction, so I need to think of a fraction times a fraction times a fraction. That would equal 1/8. Now, the nice part about this is it's multiple choice, so you can kind of look and see, oh, it's probably 1/2. But remember on a couple problems ago, we did 2 times 2 times 2, and that was 8. So that's, another hint there. But if you do 1/2 times 1/2 times 1/2, and you remember your multiplication rules, you just multiply straight across in the numerators. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So that is 1/2 is our perfect cube for 1/8. So I'm going to write that first term, rewrite the first term as 1/2 f, parentheses around that entire group, cubed. And that, if I multiply this out, 1/2 f times another 1/2 f times another 1/2 f, I would get my 1/8 f cubed back. Okay, so I'm rewriting this to look different, but it's still an equivalent expression, okay? And then we already talked about 1 as well. 1 is pretty easy. It's itself if you cube it. Okay, now this, let me grab my highlighter. This is like our A in this formula. And this inside here, so you're just looking inside the parentheses, that's like your B. Okay? So now we're just going to fill in over here. We're just going to put A, B, A squared, A times B, B squared. So we would have 1/2 F minus 1. Okay, so 1/2 F minus 1. Then 1/2 F squared. Now the trick here is you already have parentheses. You're going to put 1/2 F squared. You want to square that whole thing. So we're going to actually take 1/2 F times 1/2 F to simplify that. We'll do that in the next step. Plus A times B. A is the green highlighting, so 1/2 F is A, times B, times 1. So you can write times 1, but you can also just kind of do a little bit of simplification there. Since it's 1, it's nice and easy. Just remember 1/2 F times 1 is 1/2 F. So we can just leave it. We don't have to put the 1 in there. Now if it was 1/2 F times 2, then you would actually, probably want to put parentheses times 2 right there. Just so you can not do too much in one step and get messed up. And then B squared. B is 1. So we have 1 squared. And again, you could just write 1 there if you probably can do 1 squared in your head. Okay, now we're almost done, except we're just going to simplify. So in the first parenthesis, there's not much to simplify. Here, if we do 1/2 times 1/2, that gives us 1/4. F times F is F squared. And then here again, we just have 1/2 F, and 1 squared is 1. So that matches option A. I hope that helps.